Okay guys, so let's talk about number 9, and I might even be able to do 10 in this one video. So it's saying let's solve this system of equations using back substitution. So back substitution just means you're going to take some data and plug it back into the previous equation, and then take that data and plug it into the previous equation. So notice down here, we already have z solved for. So when it says solve by back substitution, what that really means is that we're going to take this data and plug it back right here into this z. So that would be y minus 2 times negative 1, because the z is equal to negative 1 equals 4. Y plus 2 equals 4, subtract 2 from both sides, and I get y equals 2 when z is negative 1. Now notice I have a z and a y. In this original first equation, I have an x, y, and z, but now I have the numerical value of my y and my numerical value of my z. So when we back sub, we're going to back sub both of these values into that first equation. X minus 4 times 2, because that's what y is equal to, plus 2 times what the z is equal to, which is the negative 1, equals 7. So I have x minus 8 minus 2 equals 7. Combine my like terms, that would give me x equals negative 10. When I add 10 to both sides, I get x equals 17. And so my answer would be x, y, z. Now look at number 10 for me. This one's fairly straightforward. It's just essentially seeing if you know how to say the size or the dimension of each matrix. And so the way it goes is you put your rows first. This is 1 row, 2 rows. So this is a 2 by, and your columns is next, 1, 2, 3 columns. So the size is a 2 by 3. This has 3 rows by 1 column, so that's a 3 by 1. And here we have a 3 by 3. There are 3 rows and 3 columns, and so it's a 3 by